Alright, Firestarter 16 is going to finish going over the Basics of Geometry worksheet. Now, basically, don't think of that as like a worksheet like you have to do on your own. That was more of a, like, basically a learn by doing, a learn by examples, kind of more notes. Think of it more as like a note worksheet. I'm going to kind of walk you through each of it. Some of the things that I thought might be helpful is I included a list of stuff that might show up. So the first part is right here is just different symbols you're going to see. These are really important when it comes to geometry because symbols mean a lot of different things. It's super important to understand that when you write in geometry, it depends what you write, whether you put a capital letter or lowercase letter, whether you put an equal sign or congruency symbol, whether you put a regular angle symbol or a right angle symbol, whether you have the little m or you don't, all that is important to go forward. So, basically, we're going to go through this and I'm going to show you all this stuff. So congruent, that is kind of like equal sign, but not. So equal would be like all numbers are equal to, like numbers are equal to one another. So if I say 5 equals 5. So if I'm giving you a number answer, I'm using equal. So I can say the length of something equals this. Congruency is a good way to explain, like a good way to explain congruency would be like I have identical triplets. They are congruent to one another because they are not the same. I have my first triplet baby. Her name is Ava. She looks she looks almost exactly like her sister Lainey, but they're not the same. That's why they're not equal. They're not one is the same as the other. They look the same, but they're in different spots. So a lot of times with shapes, it's congruency. We have right angles, so look, we don't use that one a lot. A lot of times we use just this. So that's an angle, all right? That's if you're naming it. Use little m if you're giving the degree, you're saying the measure of the angle. So if you're giving me a number answer, that's that. Parallel. Parallel is just two bars. Mine are always slightly slanted. They don't. A lot of times on print, they are straight up and down. Segment. Two capital letters. So, right, if I had A, B, if I use segment, I'm talking about the point, I'm talking about from here to here, right? If I use the line symbol, right, I'm talking about line going on forever. So segments are a cut portion. Lines go on forever. We have a 90-degree symbol. Congruent angles, that's something we're going to talk about. Congruent segments, those are little dashes, that's going to be important. The other thing we should talk about is how to use protractor if you've never used that before. Notice, look, an angle DEF, this is a 50-degree angle, not a 130-degree angle, because we can obviously see it's less than 90. If the angle went over here, right, that's like 121 degrees because we know that from here to here is bigger than 90. So you have to know the difference between acute, obtuse, and stuff like that. The other thing that would be very helpful, and hopefully, is angle relationships. So the other one thing that's important is to understand that all the time, no matter what you see on your paper, you can always have vertical angles, complementary angles, supplementary angles, a linear pair, and one thing we'll talk about is like all the way around. That's where, the entire thing, it kind of actually shows it right here too, right? All the way around a circle is 360 degrees. So the only time you can have these ones right here is if you have two parallel lines cut by a transversal. So if I make these two lines right here, right, sometimes you'll see a little arrow there. That means parallel. So that means this is parallel to this, right? If there is a line cutting that, this is two parallel lines cut by a transversal. The two black lines are the parallel lines. The blue line is the transversal. If you have that, right, they talk about these different type of relationships. We'll get a lot more detail with these, but basically, we'll talk about alternate interior. That'd be two angles on the same side. So if I was talking about this angle, the alternate interior angle would be the other one alternates on the opposite side, and they're both inside. All right. Alternate exterior would be this guy's on the outside of the parallel line, so I go the other side of the transversal, right? And there would be that would be his partner, the alternate exterior. Corresponding angles would be like, this is the top left angle of this group of angles. This is the top left angle of this group of angles. This would be the corresponding. And then same side interior, look, they're on the same side of the transversal. They're on the inside of the parallel lines. So basically, a lot of times, and this is a lot of times, these corresponding not so much. These words, right, refer to the parallel lines, right? Whereas these words refer to the transversal, or in relationship to the transversal. So we'll get a lot more detail on that. So that's just kind of a quick overview of everything we're talking about. Alright, so I'm going to continue. I'm just going to go through this. We already did number 1, so if you didn't do number 1 real quick, you should have got 67 millimeters. Remember, it's in millimeters. I did 2 in class, but if you weren't paying attention, so we're just going to measure it. Remember, we're going to use the millimeters, so that means you're going to be on the centimeter side of your ruler, and you're going to count each individual dash. There's 10 it's in tenths in between centimeters and millimeters, so that one you should have got 20 millimeters, right? We should have got 27 millimeters for 3, and then you should have got 52 millimeters for 4. 6, we have 8 and 9x. So remember, we're going to break this into pieces. So that's a big thing. We want to break this into pieces. So I have this, I'm going to call this a purple piece. So I have this purple piece right here, and I have it with the red piece. Together, it's going to give me the entire piece, which is blue. So I have 8 plus 9x equals 17x. So that's the geometry. The segment addition postulate says that you can take the 2 pieces together and they give you the whole piece. And now I'm just going to use PEMDAS backwards, but I'm not going to do that yet because I'm going to move my 9x over. So I'm going to put all my x's on one side just like we've done before. I end up with 8 equals 8x. Divide both sides by 8. Just simple solving. This is easier than any solving we did beforehand. X equals 1. Now in the future, I'll probably tell you to find I'll try to find the length of a segment. So I'll use some names of the segments. Like I might say, find JK. And at that point, you would say JK equals 9, right? Because you'd plug 1 in for X and you'd find that out. All right, so something very similar that we're going to do. So I got this purple piece right here. I have this green piece right here. Oop. It's equal to the blue piece. So I'm going to have 2x minus 9 plus 9, because that's the green piece, equals the whole piece. So we're always going to put the whole piece after the equal sign by itself. Now I have the 2 pieces together, adding them to give me that. So this is going to work actually really easily. Look, if we notice negative 9 plus 9, that's going to cancel. Those cancel. All right, so we end up with 2x equals 3x minus 9. A lot of you would like the variable on the left, so even though I probably wouldn't do this, I'm going to minus 3x from both sides. I get negative x equals negative 9. Now I divide both sides by negative 1. I get x equals positive 9. Done. All right. Do the exact same thing in 8. So look, I have a purple piece. I have a green piece equal to the blue piece. So I'm going to take my purple piece, 11. I'm going to add it to my green piece, which is 2x plus 23. And it's going to be equal to my blue piece, which is x plus 23. All right. Now, Remember, you always combine like terms first, so before I do anything, I'm going to put my numbers together. So I get 2x plus 34 equals x plus 23. I'm going to subtract x from both sides, because I want all my x's on the same side. I end up with 2x equal plus, I'm sorry, I'm totally messed it up. I get x plus 34 equals 23. Then I'm going to subtract 34 from both sides because I want the x by itself. So I end up with x equals negative 11. That's okay that it's a negative answer as long as when I plug it in, it does not give me a negative answer. Right? If I plug it in, it will work out. So you could always check your work here too. You could plug it in and make sure that the numbers add up. So if I plug in negative 11 there, I get negative 24 plus 23, or negative 22 plus 23. I get the green piece to be 1. So if I said CD equals 1. All right, BC, that's the purple piece, equals 11. I'm going to put negative 11 in there. Negative 11 plus 23, so I'm going to put negative 11 in there, is 12. So I get BD, that's the whole thing, equals 12. Well, does 1 plus 11 equal 12? It does. That means I did it right. That's it. All right, I did 9. So remember, you're going to use a protractor. I don't have a protractor, so I'm just going to kind of do it by hand. I'm going to kind of freehand it. This takes a little bit of skills, so you got to understand some stuff. Like I know that's 90. I know that's 180. I know half of 90 is 45, so I know that is 135. So I just keep on cutting things in half. So like I know that is going to be pretty close. So half of between if this is, hold on, we'll fix this. So right here I know is 135. I know this is 90, so I know that's 45. So I know this is, if I cut this exactly in half, that's 90 plus 22 and a half. That's like 112.5. So it's really close to that. So I'm going to go really close to that blue line. That's just me without using a protractor. And that's how I know which one I want to do. So, boom. That's pretty close, right? 165, so same thing. Here is, well, there's 90. There's 180, because all lines 180. Here's 135. So that's 135, right? If I half this, this is 45, all right? So if I cut that in half, it's 22 and a half. 22 plus 135 is 157, so it's really close to halfway in between. It's a little bit more, it's slightly more. So I'm just going to kind of go, I'm going to go slightly more than halfway. So I'm going to clear all that now, and that's just what I would do. That's how I figure it out without using a protractor. Not that the protractor is better, it's a little bit harder to use a protractor on the screen. So it should be something like this. All right. And then 155, so same difference, same idea. It's just a little closer to 135 than before. All right. 13 is acute because it's smaller than 90. This is a straight angle. This is obtuse. This is obtuse. Name the angle in 4 ways, right? So the first way I would like you to learn how to do it every time is using 3 letters, right? The vertex has to be in the middle. All right, I did number 17 in the one fire starter video. So my first priority is I want you to say UTS, so angle symbol UTS or angle symbol STU, but T has to be in the middle. If T is not in the middle, you're wrong. All right. Now I don't mind this if there's a, so number 3 is I'm totally fine with. So I just put angle 2. So you have to use. Notice I have all these at the angle symbol. My least favorite and least likely to use or accept for full credit is angle T, but it is okay if that's the only option. All right, it's not very common that you allow that. So 19, my number one priority is angle ABC or angle CBA. If B is not in the middle, you're wrong. All right, B must be in the middle because B is the vertex. All right. I also could say angle 1, and I would grudgingly accept angle B if the picture allows it, and this time the picture does allow it. All right. So it's funny. The 20 has the exact same answers as 18, where UTS is acceptable. S is my number one priority, along with STU. Either one of those are okay. Angle 2 is fine. Angle T is grudgingly acceptable. All right. The keyword is scissors. The keyword is scissors. All right, so the angle addition postulate is very similar to the segment addition postulate. We have a big angle. So the biggest angle that you can see is angle LKJ. So I'm going to call that blue, or JKL. So that is blue. All right. The other angles I'm going to see is I'm going to see green. So this guy, LKN, I'm going to call green, or NKL. So there's the green. And then I don't know JKN. So notice they don't tell me that, so I'm going to call that, if I don't know, I'm going to call it X. So I have X, and notice the purple and the green together make the blue. So I'm going to say X plus 85 equals 119. A bunch of us are going to not write it this way. You need to write it this way because it's going to get more difficult later, and this is going to be the way to do things when it's more difficult. So we're getting used to writing it as an algebraic expression because now we're just using simple algebra, minus 85 from both sides, right? So then we're going to end up with X equals 34, and it's a degree. So the way I write this answer is not this. I'm actually going to say, see how it says you have to go back to the original problem, and the original problem says find the measurement of angle JKN. So your answer is the measurement of angle JKN equals 34 degrees. All right. Now I'm going to do the same thing with 23. So I'm going to identify the big piece first. That's QRS or SRQ. So find SRQ. We don't know that, right? So I'm going to say that's equal to X. So equal to X. Now I have a green piece. We're going to say QRF or FRQ. So that's 96. And then I'm going to have a purple piece, SRF or FRS. So I'm going to say plus 25. Now this one's really easy. It's not even solving at all. I just say X equals 96 plus 25 is 121. And it's a degree symbol. Don't forget your degree symbol or you're not telling me the right answer. Now, my last part is to say, what did they want to know? They want to know the measurement of angle. So the little m means measurement of angle SRQ. And I put 121 degrees. Right? So 24, same exact thing. I find the biggest angle first, UTS. So UTS is 136. So I know my equation is going to be equal to 136. Then I find a piece. We'll say UTE. That's green, so that's green. So I'm going to say 26 on the other side. Now purple, ETS. I don't know ETS, so I say X. If you don't know it, you just say X. Now I solve. I minus 26 from both sides. I end up with X equals 110. Now remember, it's in degrees. And the last thing you're supposed to do is you're actually supposed to tell me what you're supposed to find. So the measurement of angle ETS is 110 degrees. And that's it. All right, we're going to finish up real quick. So, name the relationship. Remember, we talked a little bit about this. A and B are next door, so they are adjacent, right? But they also create a line. So the best answer for number 25 is a linear pair because together they are two angles right next to each other that equal 180 degrees. 26, I have angles that are across the street. See how they are right across from each other, right? That means they are vertical. So vertical angles. And I can even go further and say all vertical angles are congruent. Now, This, right away, I should see two parallel lines. That tells me they're parallel. So I know, and then, so if you remember from the beginning of this video, we talked about the two parallel lines. So this is a parallel line, this is a parallel line, right? This is called a transversal. So that means more than likely we have something to do with our two parallel lines and transversal. Not always the case, but sometimes. Now, if I notice that B and A are on opposite sides of the transversal, so that means we're going to say this word alternate. Now, I look at the parallel lines. They are inside, so they are interior. Right. 28 is another linear pair. You could also say adjacent, but because they create a line, we just say linear pair. That's a better answer. Adjacent would be okay. Linear pair is better because all linear pairs are adjacent. Last one, 29, 30, 31, and 32. All right, this is how you write. You look at a picture and you identify the given information. So 29, I look at V, I look at U. Those arcs mean congruent angles. So I have to know that this is the congruent symbol, and I have to use my three letters. So I'm going to say U, V, W. So angle U, V, W. That's U, then goes to V, then goes to W. Now I'm going to talk about V, U, W, because that's this angle right here. So I'm going to say V, U, W. Whatever angle you're talking about, the vertex must be in the middle. And I almost forgot my angle symbol. And both of them have to have an angle symbol. So there's one thing. Now the other, and this is easy on this one because it's in red. If it's in red, it's not part of the, it's given to you. So that usually means parallel. So I'm going to say V, W. Now I'm talking about a line. That's why I have to have the line symbol. That's why it's so important to understand that above the letters is super important because it means whether it's a segment or a line. And I'm going to say parallel to the other line, XZ. And they have to be lines. If you don't put those there, you're not telling me they're lines. Right? And then the other thing I see is I see these angles together. So I'm going to say angle YXZ. So that's this guy right here. Because I went, X is the vertex. I'm going to say is congruent to angle XZY. Alright, that's what I'm doing. So, 30. First thing I see, those dashes. So that means congruent segments. So I'm going to say E to C. I got to put a bar on top, so I know that we're talking about a segment from E to C. If I don't put a bar on top, it could be talking about a line. I could be talking about just two random points. Right? Now I'm going to say C to B. So I put the congruency symbol because they are in different places. That's why we use congruent. They are not equal to each other. Slightly different. Now I'm going to pick this angle. CE is the vertex. So this and this is going to tell me that we have congruent angles. So I'm going to say angle FEC. You could say FEB if you wanted to. Is congruent to angle ABC. Notice I have to have the congruency symbol. This right here tells me we have a right angle. So I'm going to say the measurement of angle DCB equals 90 degrees, or I could write out angle DCB is a right angle. Right? That's 30. So 32. I'm just going to identify all the first red I see is parallel. There's those little arrows. So in this problem, we used two letters, capital letters, with a line to tell me that it's a VW is a line. Now, a lot of times, sometimes lines will be written with a lowercase letter, just another way to write lines. And that means that I can use that to identify the line. So sometimes you'll see something like this. You'll see H is parallel to G because lowercase letters, in this instance, usually talk about lines. So that means H is parallel to G. Now, I see angles, right? So I'm going to say angle TSR. Remember, that means I'm talking about T to S to R. So I'm talking about this angle right here. And then I'm going to say SRQ or QRS. It doesn't matter the order of your three letters as long as and I'll use QRS. QRS. And the other thing I see is I see congruently symbols. So that means I have segments. So if I see something dashes, that means segments should be congruent. So I'm going to say SR is congruent to QP. It has to have the little bar on top to tell me we're talking about a segment. All right. 32. So I'm going to start off with the first thing I see that right angle. So I'm going to say the measurement of angle TVU equals 90 degrees. All right. I also see congruent symbols for segments. So I'm going to say VT is congruent to VU. And then I see angles here and here. So I'm going to say angle VTU, because look, I had to go from V to T to U, and then VUT. So it's congruent to angle VUT. And that finishes that.